tomorrow. All right, so we're getting into 1.68 quadratics. I will answer questions from the homework, but I'm going to go through the lesson first because I want to get through all these problems. Because most of this should be kind of a rehash on how to solve stuff. So some of you might, as soon as you see like an example, will know how to do it, and you can start on the homework. All right, a quadratic equation is one that has ax squared plus bx plus c equals 0, where a, b, and c are all real numbers, and a is not 0. So basically a quadratic is something that has x squared in it. All right, that is your highest power. And they're all real numbers. Or it could be y squared equals z or something, but we have a square in there. The first way to solve it is a case where our b actually equals 0, or we just have something squared plus c equals 0. And these are actually all examples of such ones. So our first one we have is, so for any real number k, the equation x squared equals k is equivalent to, well, I would just take the square root of both sides. So that would be equivalent to x equals, and don't forget about the plus or minus square root of k. Once again, that is just taking the square root of both sides. That's all we did to get x equals plus or minus square root of k. All right, let's go through some of these examples. We have x squared minus 9 equals 0. So that meets the letter of the law, that ax squared plus c equals 0. Well, what we're going to do is you're going to first of all move that 9 to the other side so we can actually solve it. So we're going to move that 9 to the other side to give us x squared equals a positive 9. Well, now we just take the square root of both sides. So if I take the square root of that side, square root of that side, we're going to end up with x equals plus or minus the square root of 9, which is going to equal plus or minus 3. So there's two answers. There's positive 3 and there's negative 3. You can either leave it like this, or you can actually put it in that 3 comma negative. Nope, I should probably put negative 3 first. Negative 3, positive 3. Those are our two answers. That's the solution set. So you can either leave it like this, or you can put it like that. Our next one says 2x minus 1 squared. Now, some of you might actually square it first and actually do a binomial times a binomial, but you do not need to do that. Because once again, I just have a squared on one side and a number on the other side. So I can actually take the square root of this side. And the square root of that side would just have the square root, and the square would cancel out, and I'd just be left with 2x minus 1 on the left-hand side. Well, what I do to one side, I have to do to the other side. So we'd have the square root of 0. The square root of 0 is just 0. So now we just have to solve for x, which would be adding 1 to both sides and then dividing by 2. So we just have x equals 1/2. In this case, there is just one answer. So our quadratics will either have two answers, one answer, or no answers. Or actually, they'll also have answers because we have imaginary solutions. All right, next one we see if we have x minus 3 squared plus 8. Well, this is a perfect situation to subtract 8 from both sides. To rewrite this as x minus 3 squared equals a negative 8. And I think I'm going to slide this over a little bit because we got to do a little bit more work on this one, just so I can write big on it. Once again, I would just take the square root of both sides. And that's going to give me x minus 3 equals plus or minus the square root of negative 8, which would be I times the square root of 8. Because anytime we have a negative in there, we're going to multiply it by I, an imaginary number. Let's go ahead and simplify this over here. So this is going to be x. I'm going to add 3 to both sides, so that would be equals 3 plus or minus I times, well, I can reduce square root of 8 down to what? What can I rewrite square root of 8 as? Megan?
2 radical 2.
2 radical 2, yep. Remember, this is just because the square root of 8 is square root of 4 times the square root of 2. And that's as simplified as we can make it, and that is actually going to be our answer. All right, the last one's pretty easy, but I want to show what I want you to do in this type of situation. I would take the square root of both sides. So square root of that side, square root of that side. You are going to end up with x minus 3 equals square root of 16. Let's do plus or minus. I was going to throw it on the end, but then it gets a little mushy. Well, square root of 16 is just 4, and when I add 3 to both sides, we're going to come up with x equals 3 plus or minus 4. In this situation, I don't want you to leave it like this, because there's actually two numbers up there. This, all we could write is 3 plus I2 square root of 2 and 3 minus I2 square root of 2. So this is fine for this answer. This one is not, because there's two possible answers that we can actually find. We can find our two numbers. We're either going to have x equals 3 plus 4, which equals 7, or we're going to have x equals 3 minus 4, which equals a negative 1. So I do want to, if you can, get both numbers. So I have my 7, comma, negative 1 is my solution set. So if you can simplify it to two whole numbers, you have to do it. That is fully simplified. For these, I'm okay with you leaving it as 3 plus or minus. So if there's a square root, just leave it like this. If there's something you can actually find that whole number for, find the whole number. That is your simplified form. Any questions about how I want these answered, I guess? And you don't have to write this. I just have to see your x equals. That is the most important part. If you know what the answer is, make sure I know you know. Circle something. Show me. Don't make me find just a square on one side, and we could put a number on the other side. The next way we could solve things is by factoring. That is when we actually have a b term where I can't just move one thing to the side and take the square root of both sides. So when solving a quadratic equation by factoring, we need to use the zero product property. That is when we have a chain of multiplication. So in this example, we have a times b times c equals 0. Either a is 0, in which case this whole thing would be 0, because 0 times 100 is still 0. b equals 0, or c equals 0. In our factoring one, we're going to come up with like this, where I have x times x plus 2. Well, x is a something, either x equals 0, or this x plus 2 has to equal 0. So our answer is either going to be plug a 0 in, you get 0 out, or plug a negative 2 in, and you get 0 out. So our first example is already factored for us. Don't do more work. I now have something times something equals 0. So either x plus 3 equals 0, or that x minus 4 equals 0. If it's x plus 3 equals 0, then we're going to have x equals a negative 3. Or we're going to have x equals 4. When I plug 4 back in, it makes this part 0. When I plug negative 3 back in, it makes that part 0. That's the whole goal of factoring, is to use that zero product property to come up with our zeros. So one method for factoring is just a guess and check method. And with guess and check method, all you're going to do is you're going to come up, because we're always coming down to a binomial. So I'm just going to go x, bless you, equals 0. And with this, our right-hand side always has to be 0 to use the zero product property. All right, what I'm looking for, we need two numbers that multiply together to give us negative 12. But when I add them together, they make a negative 1. So I get the negative 12 here, multiply to equal that negative 12, and add to give me that negative, well, that 1 is hiding right there, that negative 1 right there. Can anyone think of two numbers that when multiplied together give me negative 12, but when I add them together, they give me a negative 1? Joe?
Or negative 3 and 4.
Negative 3 and 4?
Negative 4 and 3. Wow.
Yeah, negative 4 and 3.
Wow.
Yep. And after I come up with that, Joe, I always just double check it, because my brain does the same thing. Like, I just flip the signs, because I'm just like, whatever. So in my head, I should think, okay, yeah, positive 3 times a negative 4 does give me negative 12. A negative 4 plus 3, hey, that equals negative 1. this one works out. So we're either going to have x equals 4, or we're going to have x equals a negative 3. Amy, let's stay up. Both are answers. That is guess and check. When it's something simple like this, I'm okay with guess and check. But I just remember in high school when I first learned how to factor, I just knew guess and check. That was basically the method we used. And it was terrible when you get to a test and you can't guess and check your way through it. And you just can't guess the thing. So what I'm going to do is I'm going to walk you through factor by grouping. I think we did this together at one point when we did SAT prep, but I'm going to do it again. This is the only way I factor. I do it every single time unless I'm using guess or check. I don't use any star methods, snowflake methods, whatever methods there are. I always do this. So the steps to this start with make 2 columns, which I already did for you. You're going to have an A times C, which I affectionately call my air conditioning column. And then I have a B one, which I affectionately call my Beyonce column. So we have an air conditioning and a Beyonce column. So A times C in this one, my A value is 2. Maybe I'll write this down. I normally wouldn't on a test or something, but my A equals 2. My B equals negative 5. And that C equals that positive 2. So A times C is going to be 2 times 2, which gives me 4. My B value is a negative 5. Note it's A times C. I'm looking for 2 numbers that multiply together to give me 4. So this is my multiplication column. Which is going to make this B column my addition column. So it's our add and multiply columns. So once again, I'm looking for 2 numbers that multiply together to give me 4, but when I add them together, they give me a negative 5. Now this is going to take care of that 2 out front. All right, this will take care of that 2. You don't have to worry about it being a 2 or a 3 or a 4. What 2 numbers multiply together to give me 4, but when I add them, give me a negative 5? Yeah?
Negative 4 and negative 1.
Yep. And sometimes you'll have a bunch of numbers in here, you're just trying things. But it will be negative 1 and negative 4. Negative 4 times a negative 1 does give you a positive 4. And when I do negative 1 plus a negative 4, I do come out with a negative 5. Now here's the whole point in doing this. We're going to separate this into a binomial plus a binomial. In order to do that, we're going to split apart this 5x. We're going to split apart this 5x into the 2 things I came up with. We're going to split it into a negative 1x and a negative 4x. Do we all agree that negative 1x plus negative 4x equals negative 5x? So I didn't do anything, I just changed the appearance of it. Now we're going to bring down that and the 2. So I'm going to bring down that 2x in front, 2x squared in front, and then I bring that 2 down as well, and that's going to equal 0. So we split and drop everything else down. Split and drop. Now we're going to focus on the 2 binomials I created. I created 2x squared minus 1x, and I also created negative 4x plus 2. And what we're going to do is we're going to factor the biggest thing I can out of that 2x squared minus 1. Well, that's just x. I only can pull an x out front, so I'm factoring out an x. 2x squared divided by x is just 2x. Negative 1x divided by x is just a negative 1. So I just factored this. We're going to do the same thing here. If there's a negative 4, you're going to want to pull a negative out front. So you're always going to pull a negative out if this first number is negative. And you'll know why in just a second. So if I look at a 4 and 2, I can pull out a 2, but I'm actually going to pull out a negative 2. I'm going to pull out a negative 2, which will make this a positive, well, negative 4 divided by negative 2 is a positive 2x. 2 divided by a negative 2 is a negative 1 equals 0. If I did everything correct, we're going to notice those 2 things are the same. If you do everything correct, that's what's awesome about this method is you have both of these are the same thing. Now all you're going to do is you're going to smush together that x and that negative 2. So I'll drop that x and that negative 2. multiply it by 2x minus 1 equals 0, and now it is fully factored. And yes, it takes a while when I explain it, but when you do it on your own, it gets faster and faster and faster, and you can do these really rapidly. Well, now we actually have to come up with our solution. So either that x minus 2 equals 0, in which case x would equal 2, or this 2x minus 1 equals 0, which would be adding 1 divided by 2, our x would equal 1/2. And those are our zeros. X equals 1/2 and x equals 2. Questions on any one of those steps? What I want you to do right now is try it on this one. In fact, let's start real quick. Is this set up to be factored yet? What do we need to do? Math it. Yeah, Joe. Add the 12 to the other side. And then I'm going to let you do it. I'm going to be writing it down while you are working. So I'll be doing the steps up here as you are working so you can kind of check your work. And then I'll just run through it with you. It's magical. I like it. Completing the square. I think we went to. Oh, I just did that. Completing the square. I'm going to circle one of the most important parts of completing the square, and the part that everyone forgets. If you're completing the square and your coefficient of x is not 1, divide by whatever your coefficient is. And we'll see that example down here. This one, our coefficient is 1, so I don't have to do anything. Our first step when completing the square is get rid of that c value they gave me, because that is not completing the square. So I need to get rid of this because that's what they gave me. So basically get rid of the c, or however you want to put it. And the only way I can do that is move it to the other side. So we're going to subtract 7 on both sides, which is going to give me x squared plus 6x. I'm going to leave a space because we're going to use that space, equals a negative 7. So I just subtracted 7 on both sides. And I left a space because we are completing the square. I actually need a little bigger space so I can write a little bigger. Let's just do this, equals negative 7. So I got that space because we need to add something, which means I need to add something on this side. Does anyone remember with completing a square what I need to add? Yes?
You do the b divided by 2 and squared.
Yep, perfect. So we're going to have 6 divided by 2 squared, which means I'm going to do the same thing to this side, which is 6 divided by 2 squared. And some things that people kind of messed up on the test is you were just bringing down that 6 divided by 2. So this is plus 6 divided by 2. And the square happens on the outside. All right, so you just bring whatever's inside here down here and put the square on the outside. Our other side would be negative 7 plus, well, that's 6 divided by 2 is 3. 3 squared is 9. Simplifying this, we'd have x plus 3 squared is going to equal 2. Well, the whole point of completing the square is that we are not doing that. We are going back to what we started with today. And that is what happens when I have something squared on one side and a number on the other side. All we have to do is take the square root of both sides to clear that square. And then we're going to have x plus 3 equals plus or minus the square root of 2. Well, to finish this off, we're going to have x equals negative 3 plus or minus the square root of 2. I can't simplify it any further, so I'm okay with you leaving it in that form. Because either that or you rewrite it as negative 3 plus square root of 2, negative 3 minus square root of 2. I don't care about that. Any questions on that? We good? Okay, the more complicated one is the one below it. It's more complicated because we do know we have to get rid of that 4, but we're not going to do that first of all. The first thing I'm going to notice is I'm completing the square and I have a 2 out here. That has to be a 1. So we need to turn that to be a 1. Has to be a 1. To make it a 1, we're just going to divide everything by 2. Divide everything by 2, which will give us the new equation, x squared minus 3 over 2x minus 2 equals 0. Now I'm going to get rid of the c they gave me. So get rid of that guy. Or move to the other side. And so we are going to have x squared minus 3 over 2x. And it's going to be plus something on this side. Equals, well, I'm moving that 2 over to the other side, so it's a positive 2. Plus that same something. I don't care it's a fraction. Just do exactly what Ahmed said. He said take that b value, divide it by 2, and square it. So note it's a negative 3 over 2, so I'm going to put negative 3 over 2. I'm going to divide that by 2, and I'm going to square it. On the other side, I'm going to do the same thing. Negative 3 divided by 2. Divided by 2, squared on this side. Now, for this side, we're going to have x. Notice this negative sign, this negative sign. Both those negative signs mean that this is going to be negative here. And it's going to be negative that 3 divided by 2 over 2. But let's go ahead and do that division. Does anyone know what 3 divided by 2 equals, simplified? Joey? Not negative 3. Wouldn't be 6. It'd be negative 3 divided by 4. So we have minus 3 divided by 4. Let's do some scratch work. Maybe on the way left side, so some of you need to work on this. If I have 3 divided by 2 divided by 2, we're going to do keep, change, flip. So keep the top, change the sign to multiplication, and take the reciprocal of what's on the bottom. Right now it's 2 over 1, so you're going to change it to 1 over 2, which equals 3 over 4. In other words, if you have a fraction divided by a number, it is just 2 times your denominator. Okay? Are we okay with that 3 over 4 now? Okay, good. All right, so that's going to equal 2 plus, and once again, this is negative 3 over 4 squared. Let's just keep working on it. I'd have x minus 3 over 4 squared equals, well, I know it's going to be 16 at some point, so I'm going to change that 2 into 32 over 16, because this is going to be a negative 3 squared, which is a positive 9 over 16. Another thing I saw in the test. What's a negative number squared? It's positive. There are several people that missed that. Anytime you square something, it's going to come out as a positive. All right, then keep on working this down. I might not show all these steps, and I don't need to see all the steps from you if you don't want to show me all of them. We have negative 3 over 4 squared equals, and this is going to be 41 over 16. All right, now I just take the square root of both sides. Do I have this right? Yes, we're good so far. So I take the square root of both sides, and we're going to have x minus 3 over 4 equals this plus or minus the square root of 41 over 16. I'm going to kind of do two steps here. We're adding 3 over 4 to both sides, so I'll have x equals 3 over 4 plus or minus, well, just a little note to ourselves. Maybe a little note that this is the same thing as square root of 41 over square root of 16. And what's the square root of 16? I always ask the hard ones. I should ask the harder ones. But it should be 4. It should be 4. It should be. If you do it right, it's 4. So we have square root of 41 over 4, which we can rewrite as 3 plus or minus the square root of 41 over 4. Boom. That is our answer. Does anyone need me to go over any of those steps again? So real quick, what we did today is we started off with just, what if we're given things that I can take the square root of both sides on? Do it. Do not make it more complicated. Then we moved up to ones where I couldn't take the square root of both sides because x plus 3, x minus 4, there isn't a square in it. So then we have to factor. Remember, factoring, we need an AC column. We need a BC column. It works for every one of them, even if it's simple and you can't figure it out. Go ahead and do it. Then we did completing the square. The big thing with completing the square is make sure that first term is 1. If it's not, make it a 1 by dividing, and then get rid of that C value that they gave you, because you're going to create your own C value. Do all those steps sound at least doable? Okay, the homework isn't terribly long, but what I do want to do is let's go over questions from the homework that was due today if you have any. If you don't have any, just continue to work on your homework. Joey, saw your hand first. Oh, okay.
For 20, letter B, we didn't know why you used 2000 for Y. Or like you plugged it in.
Oh, okay. So they're asking when is it going to equal $2 trillion, right? Let me take a picture of exactly what you're talking about so we're all on the same page. And I can see why that would be confusing as well. So my table doesn't quite match your table. I think it says, correct me if I'm wrong, this says like amount in the billions?
Yeah.
Dollars in billions. So when they ask for 2 trillion, if I write 2 trillion, that would look like this. Oh man. I did not give myself enough space. Let's write it under, let's just create a little white space here. Nope, that isn't working. There we go. Okay, $2 trillion. What that actually looks like with numbers would be a 2, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That is $2 billion. But we're going to note that we're looking for, whatever number I put here already has billions built into it. So if I say find 1 billion, you're just going to plug a 1 in here because that stands for 1 billion. Well, 1 billion is taken care of by this part. So 2,000, it sounds really weird, but 2,000 billion is 2 trillion. That's why we had to put a 2,000 in instead of 2 trillion. Because you put 2 trillion and it's going to come up with a terrible answer. Yeah, is that what you did? Oh, okay. Yep, that's why I did the 2,000, because it's 2,000 billion. Does that clarify?
Yeah.
Okay, good. Other questions from the homework? That was a good question. All right, if there's no questions for me, continue to work. I'm going to come around and I'm going to check your homework that was due today.